Good afternoon. Welcome to this Heat Roadmap Europe webinar. Today we're going to be talking about energy savings and synergies within industry. Our speakers today are going to be Bas van Zuijlen from Utrecht University, and he's been the one doing a lot of work on this. We'll have Atli Benonysson here from Danfoss, who can give some reflections on what the role of industry is and how energy savings can play in that. And my name is Susana Paardekooper. I work at the Heat Roadmap Europe project, and I'll give a very brief introduction here at the very beginning about what Heat Roadmap Europe is and what Heat Roadmap Europe is about before we go into the real topic of today. So thanks again for joining, and if you have any questions or any comments, then please let us know. There's a chat screen to the right-hand side, and then we can talk about them afterwards, and we'll have a bit of a discussion about the things that we've talked about today. So for starters, just to give an overview of who we are in the Heat Roadmap Europe project. It's a European funded project, and we have a consortium of 14 technical partners and about 10, 12 advisory bodies. And within this group, we've really managed to get together a lot of expertises on different parts of the energy system, very specific to heating and cooling demands. As Bas is here today, also very specific to industrial demands, both expertise on buildings, but also on the industrial side of kind of producing energy supplies. So this gives you a bit of an overview of who we are here today. The background of Heat Roadmap Europe is that we've been very much neglecting the role of heating and cooling. In 2012, there was the EU roadmap by the Commission, and in that there was very little mention of heating and cooling in general, but specifically on how to decarbonize it in the future was a bit of a black box at that point in time. There's a lot of Scandinavian experience with how to plan heating and cooling, and a lot of that revolves around district heating. And those plans which did exist in that roadmap looked very much towards electrification only and didn't provide a role for district heating. So the first Heat Roadmap Europe study was more directed at how can, is this a thing? Is it possible to have district heating in an energy planning system for heating and cooling of the future? And from there, it really expanded. So in 2013, we were looking more at what is the balance, and in the end, it turned out to be much more what are the synergies between heat savings and heat supplies at an EU level. In 2015, at the Stratego project, it turned more towards what can be the heat roadmaps for different countries. So when we zoom into the way that countries are developing their low carbon heating and cooling strategies, what are the different technologies that play a role? And if we integrate these things like energy savings, electrification, and district energy, what can we move towards? And that specifically is what we're trying to do for 14 EU member states at the moment. So we're trying to create evidence to support the long-term energy transitions at local, national, and EU level, but specifically within these 14 EU countries at the moment. And we do that by quantifying the role that different alternatives can be in the heating and cooling sector, and addressing the different elements that come of it. So the demands in the buildings, the demands in the industries, and the different types of technologies and savings that can happen. Underlying this kind of direct purpose for the project is a pretty strong belief that the impact that we have in the heating and cooling sector needs to contribute towards a fully decarbonized energy system in the end. So that means that the things that we do in the heating and cooling sector can't negatively affect the power sector or the transport sector or those kind of things. So that's a brief overview of who we are and the different expertises that we've gathered. A bit of a background of why we do this, and the purpose of the project. In terms of the concrete outputs, we're developing these heat roadmaps for transitions. And the way that we're able to do that in such a holistic way as what we think we do it is because we have all these different people involved. So we can consider both the local nature of the heating and the cooling. If you attended some of the previous webinars, we've done a lot of very kind of fine-grained mapping in terms of how we spatially distribute demands and how we spatially distribute supplies in what we call PETA, the Pan-European Thermal Atlas. And as I said, we have this idea that what we do in the heating and cooling sector should contribute towards the decarbonization of energy in general. So we put a lot of effort into considering the wider energy sector. How do we interact with the power market? How do we interact with the transport market? And how do we interact with the built environment? And there'll be another webinar coming up soon, I believe, about specifically kind of the energy savings in the built environment. And using all these elements, we want to create these roadmaps so that they are technically possible. We don't want to rely on technologies which aren't really currently in existence. I mean, it would be very easy to make a roadmap where we say that we rely on carbon capture storage, and from there on, it's very easy to decarbonize anything. But we want to use technologies which we have a high level of trust and a high level of degree in today. And we'll talk about that a little bit later on when we say, you know, what is possible to develop in the industrial sector specifically. And socioeconomically feasible, because I think we can all agree that there's no point making a big plan which will leave us all worse off than we are in the first place. So that's a bit of a background of these heat roadmaps that we're trying to develop. We're expecting to be able to put these out at the end of the summer, so at the end of August. And as I mentioned, we'll do them for 14 countries. So that's what we're working towards. In terms of the methodology, this is a bit of a complicated slide, but I think that Bas is going to explain some of the things, specifically how the forecast model is used and how we move that into the energy models later on. But I think it primarily serves to emphasize that part of the reason that we have such a large consortium and part of the reason that we do a lot of this work is because we use a lot of very granular detail. As I said, both in terms of the built environment and in terms of the spatial distribution of the demands and the supplies, and through that also what is the potential for heating infrastructures like district heating, like gas networks, and the energy system. So we put a lot of this effort together. And then we build reference scenarios and alternatives with the aim of being able to really support this evidence and quantify this evidence towards these heat roadmaps. And in that whole kind of ecosystem of the knowledge that we're developing and the tools that we're developing, industry has played an important role, because so far industry has been something which is very, very easy to neglect. I mean, we all know about buildings, so we work with buildings. But one of the really novel aspects of this project and of the way that we've been approaching making these holistic energy strategies is that we've been able to include industry, and that we've been able to really have a nuanced view of how it happens. So with that in mind, I'm going to let Bas explain it in much more detail. And I hope that it's interesting for you, and that if you have any questions, you'll feel free to ask them later on.
Yes, thank you, Susana. Thanks for the introduction into the project. My name is Bas van Zuijlen. I work at Utrecht University at the Copernicus Institute for Sustainable Development, and my specific focus is on renewable energy. And of course, the most sustainable form of energy is energy that you do not use. So for this project, we are focusing on saving heating and cooling demand for industry. So the outline for the webinar today is, first I'll talk a bit more about the broader heat roadmap for framework and how these cooling and heating cost curves fit into this framework. I will discuss the methodology that we used, both the more general approach, because we also developed cost curves for the built environment. So we aligned our method with the cost curves for the built environment. But of course, focusing more on industry, we have some small tweaks that really fit with how heat is saved in industry. I will also discuss a little bit the baseline heat demand in industry, because the cost curves are very much linked to this baseline. Then I will discuss the results that we found, and both in terms of costs and also in the energy savings potential in industry. And finally, of course, I will have some conclusions based on these results. And if you have some questions, please save them, submit them, and we can discuss them after the conclusions. So first of all, the position of the cost curves in the heat roadmap project. As you can see, we will be focusing on this part for the webinar today, and specifically even more only on the industry. So we will be focusing on the saving cost curves for industry. As you can see, the saving cost curves are really strongly linked with the baseline scenario, the work package 3, also done in the forecast model developed by Fraunhofer ISI. But as Susana mentioned already before, we also have quite some other approaches to finally come to a whole decarbonized energy system. So Susana already mentioned the Pan-European Thermal Atlas in green here, where we really focus on the spatial aspects of heating and cooling, and where there is possibly some excess heat potential, but also where's the heat demand. So it's really fun to play around with these maps, and they are available online. So I implore you to go to the heat roadmap website, www.heatroadmap.eu, where you can find a link to these maps. It's really fun to play around with. We also, in order to address this question of the broader whole energy system decarbonization, we also have a look at the bottom part in light blue, based on the EU Times model from the Joint Research Center, who do a complete energy system simulation. And we use these inputs also for our final optimization in gray on the right side, where Aalborg University will optimize the whole energy system, but with a specific focus on the cost curves and the heat and saving cost curves, which we'll be discussing in this webinar. So the heating and cooling cost curves were developed by TAP Energy from Switzerland, Fraunhofer ISI from Germany, and Utrecht University, where I work. These partners were the same partners that were also developing the baseline heat demands. So therefore, we really knew the data that we were working with, which made it, I think, more easy to also come up with these cooling and heating cost curves. So first of all, before we dive into the specific methodology, it's very important here to realize that we are talking about delivered heat and delivered cooling, which is something different than final energy. So in this graph, you have an overview of what the difference is. Final energy is the energy that is delivered to the end user. So if you, in your home, possibly your home is heated by natural gas, and the natural gas delivered to your door, that's the final energy. However, you have to convert this gas still to turn it into heat. So once the gas is turned into heat by a boiler, or possibly it comes from some sort of storage, that is the delivered energy. So that's the focus of this project. And note here that the delivered energy and final energy for district heating are actually the same, because there's not a conversion done by the end user. And then finally, of course, you also still might have some losses in the local distribution of heat. If you also subtract those losses, then you come to useful energy. So delivered energy, which we focus on here, is something different from final energy, but it's also not the same as useful energy. So this is the graph for the heating and cooling cost curves, and you should read this graph from right to left. So on the left point of the graph, the red dots, that's the baseline delivered heating or cooling demand in terawatt hours. But on the vertical axis, you can also see how much money was invested in heating and cooling in general in the baseline. As you move towards the left of this graph, you can see that cumulative investment costs increase while the delivered heating or cooling demand decreases. And as you can also see by the shape of the graph, the further you acquire savings for delivered heating or cooling, the more expensive they get. So you have increasing marginal costs. We developed these kind of cost curves both for 2030 and 2050, both for heating and cooling in the residential sector, tertiary sector, and in industry. So today we'll only be talking about industry, but in an upcoming webinar also the cooling and heating cost curves for residential and tertiary will be discussed. We also developed these cost curves for the 14 Heat Roadmap Europe member states, but also for these member states individually. It should be noted here that this cost curve is something different from a marginal abatement cost curve. So these are the cost curves that I think are quite famous because McKinsey used them quite often. So here we only look at the investment costs. So the change in operational costs or savings on the energy bill are not included in these graphs. So it's important to realize this. So as I mentioned before, the baseline is quite important because the baseline determines how much additional savings potential there's left. So I will also shortly discuss what happened in the baseline. The baseline was developed for the year 2015 as the base year, but then also projected into the future for 2030 and 2050. And basically what we did with the baseline was really disaggregate the total heating demand into all sorts of smaller sub-parts. So we disaggregated it based on energy carriers, so maybe the fossil energy carriers, but also renewable heat sources. We also disaggregated it based on sectors. So this is really useful because now we look at industry, so we can specifically see what amount of the baseline heat demand is used by industry. Finally, we also even disaggregated it based on the temperature levels or the end use, and also all the technologies that were used. So this is of course very important. How is the baseline made up? The baseline is based on the EU reference scenario 2016, or at least the activity data in industry is aligned with this scenario. So we assume the same amounts of activity. The CO2 price increases from 2015 of about, well, what are we at the moment? A few euros per ton, up to 90 euros per ton in 2050, also based on the same EU reference scenario. Additionally, we assumed that current policies will remain in place and no other policies will be applied. So you can think about the EU Eco-Design Directive. We also tried to include some local support schemes, but because these differ per country, it's really hard to completely include all of them. But the stronger these local support schemes were per country, we modeled this per country to also show more ambitious heat savings. Finally, we also performed a very extensive literature review to look at what are industrial technologies where we can save heat, how expensive are these technologies, how much heat can they save, and we updated the forecast model with these technologies. It's very important to realize that this baseline scenario, although it comes out of the forecast model, it is not a forecast. This baseline scenario could be viewed as a current policy scenario. So what happens if we leave all the current policy in place and, well, then let the markets decide what happens. So the results of the baseline, you can see here disaggregated per industrial subsector. What it shows is that for 2050, we see a decrease of almost 150 terawatt hours compared to the frozen efficiency. So the frozen efficiency scenario is the scenario where we have the same amount of activity data, so the same amount of steel production, of paper production, etc. However, there is no diffusion of energy saving measures. So we realize or we achieve some savings towards 2050 compared to the frozen efficiency scenario. However, the total heating demand is still higher in 2050 than it is right now in the baseline scenario. This increase in total energy demand comes mainly from an increase in activity data, because the energy intensity actually decreases in the baseline scenario. So this is both based due to structural changes. So we shift away from very energy intensive industries, but also because we already see some energy saving measures in the baseline scenario. Well, this is a little advertisement for all of you listening to the webinar right now. In less than a month, Tobias Vleiter from Fraunhofer SI will present more, will give a webinar about this baseline with much more detail. So it might be interesting for you to look at this as well. Also, a simplified version of this baseline is also available on our website. So have a look at this link. You can play around with the Excel file yourself. Then coming back to the actual cost curves. So in our methods, we use this forecast model, which is actually very technology specific. It's a bottom-up model. So we know about all the different technologies and all the different industrial subsectors and see how they develop over time. In this forecast model, we account for the technical limitations of these energy saving measures. So one measure can only save so much. Efficiency cannot be higher than 100%, these kind of things. But we also account for the stock turnover. So if one of the industrial technologies has a lifetime of maybe 40 years, then of course 2 years after installing this new technology, you cannot again replace it by an even better available technology. So we take into account the stock turnover. Also, we look at the differences between EU member states. Climate is maybe more applicable to the built environment, but energy prices are very important for industry, of course. And the resulting cost curves, of course, show the additional savings because beyond what we can achieve with the current policy. Now coming to more specific, the approach for industry. For industry, we have a list of 168 heat-saving measures and 20 cooling-saving measures across 7 industrial subsectors. So on the graph on the right, you can see how these measures are implemented. So for example, on the blue part, you see that for this theoretical savings measure X, we have already a diffusion of 10% in our base year, 2015. In the frozen efficiency scenario, this diffusion level for this energy saving measures remains constant. However, in the baseline, maybe we can increase the diffusion of this energy saving measure. So in this case, we can increase it up to a level of 25%. Of course, then you achieve some heat savings. And then finally, how we determine the maximum heat savings that were possible. We have the maximum diffusion scenario, which is how we come up with the cost curves. And this is the maximum diffusion of a heat savings measure that can be implemented, accounting for stock turnover and technical limitations, etc. So then we have a list of 168 heat saving potentials with costs. However, we also still need to rank these savings. And we did that based on proxy specific costs. So here you see the formula for specific costs, which is the annualized investment costs plus extra annual costs minus the annual benefits divided over the total heat savings or cooling savings, of course. However, in our case, because of the general method, we are focusing solely on the investment. We're not taking into account the savings on the energy bill because that will be done in the full energy system optimization done by Energy Plan, as I showed in the first slides. So these, the annual costs and the annual benefits will not be taken into account. So then, of this list of energy savings measure, we can basically divide them up into 5 different types of measures. So the first type is a basic measure. So these measures have already been implemented in the baseline to some extent. So if you remember the graph from a few slides back, maybe up to 25% of this potential has already been implemented. Of course, we can increase the diffusion of these energy savings measures up to maybe 80, 90, or even 100%. Then there are more innovative heating measures. So these measures have not really been implemented in the baseline scenario yet. So there, you can imagine that there is much more potential for these measures. Then, as a third part, we have structure-based heating saving measures. So these measures are not really a technical add-on which you can invest in, but it's more like changing the structure of your industrial setup. So examples are shifting away from blast furnace steel generation to electric arc furnace, or increasing the recycling rates for paper or glass, so you have to produce less primary glass and paper and can reuse more. Of course, once you start shifting or playing around with the structure of your industry, you have to account for this for the basic and innovative heating measures, because if you have a basic measure which can reduce the energy consumption of a blast furnace, if based on the structure-based measures you reduce the usage of a blast furnace, your savings potential, of course, also decreases. So we accounted for that as well. Then we also have some cross-cutting heating measures. So these are measures which can be implemented across different subsectors in industry. So examples are for steam pipe insulation, or well, those kind of measures. And then finally, also the cooling measures, of course. We looked at cross-cutting measures, so the same as the previous, but then for cooling. So then the results up to 2050, you see that we can increase the savings compared to the frozen efficiency with much more in our maximum savings scenario. So in the maximum savings scenario, you see that we can save an additional 232 terawatt hours of delivered heating, indeed, in industry. And to give it a bit of context, this value is more or less comparable with the total current heat demand of the Netherlands. So not only the industrial heat demand, but the total heat demand in the Netherlands. What's also important to notice here is that as in the frozen efficiency and in the baseline scenario, we still had an increase in delivered heat. With the maximum savings scenario, we can reverse this trend and have lower delivered heat in 2050 than we have at the moment. Then this cost curve, well, as you can see, it rather looks like the picture that I was showing at the beginning of the theoretical heating cost curve. Note here that this is the heating cost curve for both industry and also the built environment. So this is a combination of these two cost curves. What we can see is that only 1/3 of the total savings potential can be found in industry. So the savings potential purely looking at heat demand is bigger in the built environment. However, we find that the savings in industry are much more cost effective. So as you can see in this graph, while moving to the left, costs keep increasing. However, only the first part is, or most of the first part is industrial heat savings, and only thereafter you start investing in heat savings in the built environment. So then if you look at the cost curve for only industry, you can also see quite some different parts. The first part where it's really vertical, so you can have heat savings completely for free. This is based mostly on the structure-based measures. So for increased recycling or shifting away from blast furnace to electric arc furnace steel generation, these are completely for free. However, we must know that there is quite some uncertainty around these numbers. So these are big chunks of almost free energy savings. However, the costs are quite uncertain, but also the total amount of delivered heat savings is uncertain to some extent. Then afterwards, you see a small increase from right to left in costs. These are the basic and innovative heat saving measures. And then the most expensive heat saving measures, so towards the left side of the graph, those are the heat saving measures in industry where we are saving space heating. Well, as you can see here, there are quite some differences between subsectors. This graph shows the share of the delivered heat savings per sector for each of the countries, both in 2030 and 2050. There are some differences between the countries. Some countries might have almost no steel industry or less paper industry. Of course, there are these examples, but a general trend that arises is that most of the savings can be acquired by iron and steel and in space heating. And actually, we should note here that space heating is not a sector as such. It is, of course, achieved across multiple sectors, but because the potential was so big, we decided to show it as a separate sector in this graph. As you can see, for the 2030 total space heating potential, it decreases up to 2050. And it's not only the share that decreases, but also the total amount that decreases. And that basically has to do with the baseline scenario. Because in the baseline scenario, we have much higher space heating savings in 2050 than we have in 2030. So the potential more or less dries out. Then we can, of course, also look at the heating cost curves per country. And it's important in this graph that you note that both the vertical and the horizontal axis are indexed, because otherwise, of course, when you try to compare Belgium with Germany, Germany has quite a big industrial sector, and Belgium, it's less so. So then the total values might, Belgium might not really show up in the total heat cost curve. So here on the horizontal axis, it's the remaining percentage of the baseline delivered heating. So the more you move towards the left, you have increased savings, and there is a smaller remaining percentage of the baseline delivered heating. On the vertical axis, you have these proxy specific costs, which I was talking about earlier. And this graph allows you to see for each country if it can acquire savings relatively cheaply or relatively expensively. So the countries Hungary, Italy, and Spain really at low costs can achieve more than 15% heat savings, while, for example, the Netherlands and Finland and Germany, the cheap potential relatively quickly runs out, and then you have to switch to more expensive heating savings measures. It's also quite important to notice here that we have no savings that go beyond 82% of the baseline heating demand. So the total savings potential remains rather limited. This has to do with the thermodynamic limits that we have in industry quite often. So at a certain point when you're producing paper or generating steel, you just need a fixed amount of energy at the minimum. Those are just thermodynamic minima, and we cannot change that. So then, of course, we're also looking into cooling in this project. I compared the cooling savings in industry on the right with the cooling in the tertiary sector. As you can see, we did not assume any cooling savings in the baseline compared to the frozen efficiency scenario for the industrial sector. However, for the tertiary sector, we see quite considerable savings of almost 200 terawatt hours between the frozen efficiency and the baseline scenario. In the maximum savings scenario, however, the difference between the industrial and the tertiary sector compared to the baseline scenario is not really big. So we can only add about 30 terawatt hours of delivered cooling demand on top of the baseline scenario, both in the tertiary sector and in the industrial sector. So again, a similar graph as I showed before for the heating cost curves, but now for cooling. Again, you can see that Hungary has quite a large potential for heat savings at relatively low costs, while Germany again and the Netherlands can only achieve relatively less savings and have to switch to higher cost measures more quickly. The total amount of savings, however, are on a percentage basis much bigger for cooling compared to heating. So then to the discussion, and I'll mainly focus this on the position of the cost curves that are within the heat roadmap. Because we focus on delivered heating and cooling, this is not really what most experts use. So usually these savings are reported in final energy demand. So therefore, these values in euro per megawatt hour saved might not be easily recognized. And also, we do not include savings on the energy bill in our cost calculations. So therefore also these figures might seem too high to other experts in the field, although of course it mainly has to do with a difference in methodology. The cost curves also do not include demand-side supply technologies. So for example, investing in a more efficient boiler is not included in these cost curves. It will be included in the final optimization, however, not in this part of the heat roadmap project. Also, and this is especially relevant for industry, quite some of our saving measures that we looked into mainly save electricity and also save a little bit of delivered heating or cooling. So, but you can imagine that when we calculate the specific proxy-specific costs, these measures might become might seem much more expensive because we only focus on the delivered heating or cooling savings. Well, actually, someone working in this industrial sector will look at the total picture and also save electricity. Therefore, the total savings might be cheaper than we show them in our cost curves. However, of course, we chose this method of looking into delivered heating and cooling demand with a purpose. It really helps us to have an insight in where the heat savings take place. So in the final energy optimization, you might realize heat savings based on the demand-side supply technologies, but also on really delivered heat savings, which we look into here. So it really helps us to distinguish between those two types of savings. So then the conclusion of these cost curves, we can achieve really a considerable amount of heat savings and also some cooling savings on top of the current policy scenario. So there's quite some potential there. In general, we see that the heat savings in industry require less investments than in buildings. But as I mentioned before, the total potential for industry remains rather limited. So it's interesting maybe to look into new technologies or processes that should be developed if we really require that we achieve further heat savings in order to get beyond this 82% that I showed. Also, the low-hanging fruits here I showed are the heat savings based on the structure-based measures. So where we combine both the resource recycling with heat savings. So then we also save the energy that's embodied in this resource as well. So for further policy development, we see that there is this large savings potential. However, it remains untapped in the current policy scenario. So we really, if we want to achieve further heat savings, we really need to start thinking about maybe a higher CO2 price or other measures which bring industry to do further investments into heat savings. Also, currently a hot topic, I think, circular economy in policy making also helps to reduce heat demand. So therefore, it's interesting to look also into this synergy. Well, this was my webinar so far. So if you have some questions, please ask them now. If you still have questions after the webinar, please also feel completely free to send them to my email address shown here on the slide. If you want to have a look at more detailed information, you can find it on the Heat Roadmap Europe website. I showed the links here, but if you go to heatroadmapeurope.eu, you will also surely find it on the website. And with that, I would like Susana to maybe open the discussion.
Yeah, I'd be happy to. Like Bas said, there's a lot of information, especially about the baseline on the website, so you can go have a look at the Excel yourself and also look at the other outputs that have come from our project. But I think at the moment, I'd like to invite you to make some comments. I think Atli will start us off. And then from there on, let's take the discussion.
Yeah, thank you very much, Susana. And thank you very much, Bas, for this interesting presentation. Very interesting topic, and I can see there is really a lot of data, a lot of analysis behind. Yeah, I have few questions, consideration, but I will only start with a couple for now. It is for me very interesting to see that the saving measures in the industry are in relative terms almost cheaper than they are in the built environment. Although, as you say, that the saving potential remains limited. And there, of course, not least this flat curve, or flat part of the cost curve is very interesting, where you're basically getting the savings for free. Now, if you think about the policymakers, presumably the cost curves as such as not so actionable for them. So I would assume that it would be good with more like a pixie book explanation on what is this flat curve, how can we realize this because savings on a flat curve, we basically get savings for free, and of course can address the uncertainties that you also mentioned around it. So this, if you could comment a bit on that, or how you see that, how this could be done more actionable, like put in a form, or if it's already planned to put in a form that will make it easier for policymakers to take outset. Another thing is that I have seen, I looked a little bit in your background material, that of course space heating is a part of this the heat consumption in industry, and as I understand, then there are relatively rough assumptions there, assuming that we have a similar saving potential in industry as we have in the non-residential heating, the tertiary sector, and I'm just wondering if it could be that we have a blind spot there, and that the savings exactly here, the space heating savings potential might be bigger. And I am partly saying it because of our own experience here in Danfoss. I can tell we have a target of reducing our heat consumption with 50% until 2030, and CO2 reduction of that is also CO2 emission of that is left with another 50%. And in some cases, for instance, here on our headquarters, we have found space heating potentials or saving potential of up to 50%. And since industrial buildings and heating systems, they tend to be often, some of the older buildings systems are simpler than in the non-residential. So I'm just wondering if it could be that there is a blind spot there. So maybe you could comment these two aspects, Bas.
Yes, thank you, Atli. Thanks for the questions. On the first point, so there are basically three heat savings. As I mentioned already in the presentation, there's quite some uncertainty around these numbers. And these uncertainties have to do with, the fact that actually maybe there might even be negative investment. So you might even be making money while saving delivered heat. Because as soon as you start recycling steel or glass or paper, you actually don't need to invest in another steel plant or paper producing or glass producing plant. So these are parts where you actually are making money, or at least not spending money. However, this of course comes at a cost in the supply chain. So we also need to organize how we are recycling this steel, glass, and paper, and we need to improve the recycling rates that are currently assumed in the baseline scenario. So I think indeed this is where policymakers really can play a role. They can organize society and the whole supply chain of certain products in such a way that we can really achieve these higher recycling rates, and thereby also achieve these heat savings that I mentioned before. Then the space heating potential. I'm not completely sure what your question was there, but I think it was about the costs of space heating potential in industry. And our cost data are here based on the cost data that were also developed for the tertiary sector. So you can imagine that the parts of industry where we need space heating are more or less comparable to parts of the tertiary sector where we also need space heating. Maybe not completely, but this is the assumption that we made in our project. And as you also saw, that the heat savings in the built environment are much higher than in industry in general. You also see that space heating savings for industry are relatively expensive. So I hope this answers your second question as well.
Yeah, thank you. Yeah, so I'm also just raising the flag that I could imagine that we have a blind spot here for the space heating savings in industry. That might be bigger potential than in tertiary industry. But it's just something to think of. And for the first question, yeah, thank you very much. And just maybe if you could elaborate a little bit on so what is being done to make these research, let's say, understandable for policymakers, because that they really can see what are the actions that are needed to be taken to realize this low-hanging fruits. Just put a couple of words on that.
Yes, thank you for the question. Of course, I agree with you that these cost curves, as you present them just as a single graph, they are not really informative to policymakers. It's really hard to see what kind of measures are behind them and how you should read these graphs. To tackle this problem, part of our deliverables in the project was also a report on how these cost curves should be used by lead users. So, for example, policymakers, but also industry actors, and for the tertiary sector, of course, also actors in the tertiary sector. So this report really dives into more detail into where these savings are achieved and how policy can increase these potentials. Also, this was one of the links I showed on my final slide, so you can find this report on the Heat Roadmap Europe website.
Okay, thank you.
Yeah, I think one of the things that's important to note when we talk about this is that, and this is a little bit specific to the other question, but also to some of the other things that we've been saying, is that when we talk about these additional heat savings, we talk about them as additional to the baseline. So sometimes when we say things like 30% savings additional to the baseline, that can very much be 50% compared to now. It's just kind of that step into the future where we project forward and then make a saving compared to that. That can be a bit of a calculation. I have a question from Thorsten Spillman about the graph in terms of the share of total delivered heat savings per sector. But I don't know if we can move backwards in the slides. Ooh. Yeah, I think this is the one. So I think it's worth clarifying here that, again, what you talked about with the space heating, because in a lot of cases, maybe here it looks like the savings that can come out of industry are really high. But at the same time, the conclusion is that the potential for savings from industry is limited because the technical potential is limited. I think it's kind of a question again of how big is this kind of share of heat savings per sector in industry versus what is the size that can be achieved in the residential sector and service sector, or in the built environment rather. Does that make sense?
Exactly, Susana. So this graph is showing the total potential for heat savings in the industry. So heat savings in the tertiary sector or in the residential sector are not shown in this graph. So 100% means 100% of the potential savings in industry in total. And the space heating part of this graph is space heating, of course, as such, is not a subsector, but it means that this is the space heating potential in the iron and steel subsector, in the chemical industry subsector, etc., etc. So actually, the space heating component should be read as small parts of each of the other 7 industrial subsectors.
All right, perfect. I think we're almost at the end for today. I hope that answers all the questions that have been asked. I think for me, I really like learning about I mean, I know a lot of this, but we've been a big part of this project for a long time, but it's really great to see this kind of thing because as Bas said, it's a bit of a different methodology where it focuses very specifically on delivered heat. And the purpose of that is so that we can put it into these full energy models. We can put it into the JRC U times model, and we put it into the energy plan model. And it's nice to know that I'm sitting there kind of aggregating this to a very abstract number. Like I aggregate it to a 5% or a 10%. But it's really great to know that this kind of really granular level of detail exists in where that number comes from. And I think a lot of the strength of the project comes from that fact that there's very detailed sector-specific work. So I hope it's been interesting to all of you. Thank you, Bas, for presenting it. Thank you, Atli, for your reactions. I think it's very valuable to hear also what you have to say in terms of your real-life experience with Danfoss. Thank you, everyone, for attending. If you're interested in more information about this, I think this webinar will be online soon, a recording of it. And as we've, I think, both already said a few times, there's a lot of information on the website about both the data sets that are used for this and the methodology behind it. I have to make a quick overview of the webinars that are still to come. On the 3rd of May, we'll be talking about the energy dialogues at a local level. So it's a bit of a turnaround, but it's about how local governments, and that can be regional, but I think the focus during the webinar is very much on cities, can use these kind of outcomes and these kind of data sets and information tools to help them in their planning. As Bas said, on the 17th of May, Tobias Fleiter from Fraunhofer will be talking about what heating and cooling is used for in Europe, both in the industry sector, but much more in the residential and service sector. I think typically the conclusion is that we should all move into apartments and that no one should live in big suburban houses. So you can look forward to that. And then on the 30th of May, there's a webinar dedicated specifically to energy savings in buildings and low temperature heat supplies, both in terms of district heating and in terms of other low temperature supplies like heat pumps. Other than that, I would like to thank you again for being here and see you next time.